Hello students, welcome back. In today's session, we will discuss testing. So testing, it is a very important part of any product development, whether it is a software product or you can take an example of a vaccine. So in this COVID-19 situation, we know that how testing is important. The vaccine has been developed, I think, before 6 or 7 months, but from then till today, it is going through different testing phases. It has been tested on peoples in different age groups or even on the peoples with earlier disabilities. So before giving it to the general public, it has to be tested thoroughly. Otherwise, there may be some side effects later on. So testing is very important. Same way, testing in the software development is also equally important. So before releasing the software, it needs to be tested thoroughly. It has to be tested on different sets of input so that after releasing it, there should not be any errors. And it is also true that no software is 100% error free, because we cannot test it on all the possible values, but yes, we can test it on some subset of values so that we can say the software is error free. So testing is very important in any product development. So in today's session, we will study about testing. So let's start. Testing is the process of running a program to try and ascertain whether or not it works as intended. So testing, it is to check if the program works as intended, whereas debugging is the process of trying to fix a program that you already know does not work as intended. So debugging, it is fixing the program which is not working as intended. So good programmer always design their program in ways that make them easier to test and debug. So while writing our program, we need to write it in such a way that it is easier to test and debug the program. The most important thing to say about testing is that its purpose is to show that bug exists, not to show that the program is bug free. Actually, testing, it is done to show that there is some error in the program. It is not to show that there is no error in the program. So always design test cases to show the bugs in the program. The key to testing is finding a collection of inputs called test suits that has high likelihood of revealing bugs. It does not take too long to run. The main key to testing is to find the collection of inputs, the different sets of inputs, which is called as test suit, to test our program. And while designing these different sets of inputs, we need to see that it has high likelihood of revealing bugs, and it should not take much time to uh, run as well. The key to doing this partitioning, the key to doing this is partitioning the space of all possible inputs into subset that provides equivalent information about the correctness of the program, and constructing a test suite that contains one input from each partition. Now, as I have said earlier, it is not possible to test any piece of software on all the possible inputs. But what we can do is we can partition the space of all possible inputs into some subsets, and that provides some equivalent information about the program, and based on that we can construct a test suite that contains one input from each partition. Uh, for example, we can consider here a partition of a set divides that set into collection of subsets such that each element of the original set belongs to exactly one of the subset. Now let us consider this example here. We have a function that is bigger, and it is taking two values, and this, as the name says, this is bigger simply returns true if x is less than y and false otherwise. So we assume that there is a code in is bigger which returns true if x is larger than y and false otherwise. If we have to test this particular function, how would we test it? So what are the inputs for is bigger? As it is said, this x and y are assumed to be integer. So the inputs for this particular function are all sets of integer numbers. It can be 1 and 2, 2 and 3, 4 and 5. So all sets of integers are the inputs for the is bigger function. But is it possible to test is bigger on all these inputs? Then practically it is not possible, but we have to divide this input into some subsets. Okay. The set of possible inputs is all pairwise combinations of integers. One way to partition this set is into these 7. So one way to partition it into these 7 subsets. As I have said, it is not practically possible to test it on all the possible inputs, but we can divide this all possible inputs into some subsets. You can see here we can divide it into subsets like x is positive and y is positive. So in first case we may pass numbers like 1 and 2, or we may pass number like 10 and 20, that is both are positive. We can test the function for positive values. Then x is negative, y is negative. We have to even test for negative values, because as in the specification it is given that x and y are assumed to be integers. So integers can be even negative integers we can have. So we may need to test for values, that is negative values, that is -1, -2, or any other negative values like -100, -200, or some other negative values. Then x positive and y negative. So x positive, say 1 and -2. Then x negative and y positive. So x negative, say -1 and 2. Then we may test it for x is equals to 0 and y is equals to 0 also. We can have a subset like x is equals to 0 but y is not equals to 0. X is not equals to 0 and y is equals to 0. So these are some subsets of inputs by using which we can test this function is bigger. And if this function is bigger works for these subsets of inputs, then we can say yes, the program works properly. But we cannot guarantee that the program or all bugs in the programs are detected by using these set of inputs. Okay, if one tested the implementation on at least one value from each of these subsets, so we have to test it for at least one value. For example, in positive we may test it for 1, 2, one value of every subset. In negative case, we may test it for -100 and -200. So if it works for one value of each of the subset, there would be a reasonable probability of exposing a bug if one exists. But as I've said, no guarantee that all the bugs will be exposed. So while testing, we need to test the program or a software by partitioning the input into different subsets. For most programs, finding a good partitioning of the inputs is far easier said than done. So finding a good partitioning of inputs, it is very difficult for most of the programs. We have seen in the last example, we were testing a simple piece of code by using some set of inputs. But for some complex program, it is very difficult to find a good partitioning of input. It is easier said than done. Typically, people rely on heuristics based on exploring different paths through some combination of code and specification. Heuristics based on exploring paths through the code falls into the class called glass box testing, which is also called as white box testing, where the actual code or the code paths are tested, and this is based on exploring different paths through the code. And heuristics based on exploring paths through the specifications falls into a class called as black box testing. Now in case of black box testing, the actual code is not tested, but the specifications of the program are tested. So the heuristics based on code and specification, we have two testing techniques based on that. One is glass box testing and another it is black box testing. We will discuss about glass box testing and black box testing in the next session. In today's session, we will stop here. Thank you.